Okay, sixth grade, this is part 2 of homework number 7 because Mrs. Booth's phone ran out of time to record, so I had to break it in 2 parts. Sorry about that. Anyways, okay, we did this one. This one I told you, don't forget there's 2 parts. We're looking for the difference of these 2 jobs, but we want to know over a 15-year career, which means whatever you get here when you subtract, you have to multiply it by 15. Okay. Number 6. Marion was asked to create a set of numbers so that 2 were integers that were not whole numbers, 2 were rational numbers that were not integers, and 2 were whole numbers. Which of the following sets would satisfy the criteria for Marion's set? Okay. So each one of these have 6 numbers in the set. Okay, and let's just review what a whole number. So whole number equals positive whole numbers, no parts, and we start with 0. 1, 2, 3, and so on into infinity. Okay. No negatives, only positive whole numbers and no parts, okay? Then integers come in, and inside integers are all of our whole numbers plus negatives. So it's all whole numbers and their opposites. So an opposite of a positive number is a negative, okay? So, and no parts. Remember, the only place you go is to rational numbers for parts because rational numbers is our AutoZone. Okay, so that would be 0, 1, 2, 3, or it could be -1, -2, -3, so on this way, so on this way. Okay, no parts, positive whole, or negative whole numbers. Okay. Then we do rational numbers. So rational numbers is whole numbers. So anything that's a whole number goes in here. It's integers. All the integers go in here. And then all parts. It's AutoZone. So like 3/4, 25%. 3/10, 0.40, etc. All the parts. Okay. And remember, we represent it like we can do a diagram like this. And inside here is whole, and here's integer, and here's rational. So whatever is whole is in here, and the whole is inside the integer, so it's also an integer and rational. Whatever is an integer is also a rational, but remember, integers, not all integers can go back into whole, okay? So if I have a 3 and a -3 in an integer, this 3 is a whole number, but it's not an integer. Integers start here, as far as negatives start here. So no negatives. There's no negatives in here. Okay. So with this information here, you should be able to go and do what they want you to do. Okay. We're looking for 2 that were integers that were not whole, 2 that were rational that were not integers, and 2 were whole numbers. Okay. That's going to be a little brain teaser for you. Number 7. It says the number line below models an integer problem. Okay, so whenever we have these number line models, we always start where we start at 0 for our very first shift. Okay, remember these are called shifts. This is shift 1 and shift 2. We always, whatever one is on the bottom is your first shift. So that's your first action. You took this action, then you took this action. And your first action, again, always starts at 0. So we're trying to match what's going on up here in this model to what's going on down here. So on my first shift, you need to look and count how many places did I go this way. And if I'm going this way to the right of the 0, I'm going positive. Okay? When I go to the right, I'm going positive. Then I stop here and my second shift, so I'm doing something positive and then I'm taking away because I'm going to the left. So that means I'm going negative. I'm taking away, I'm subtracting, I'm minusing. Remember, negative, minus, subtract, take away, they're all the same. Okay? So I'm plus this, take away this. You're going to have to do the little jumps and see what it is and see if you can find out which one of these it is. Now, where your arrow ends up is what your answer should be. So my arrow ends up here, and that looks like that's a -3. And maybe you want to write in all the additional numbers here, so that'll help you out a little bit. So my arrow ends at -3, which means my answer has to be -3. Okay? Very easy. Number 8. An expert diver is looking for a particular species of fish along the coastline. He dives 22 feet below the surface of the ocean. Then he dives 7 more feet. He swims back up 14 feet and down another 4 feet before he finds the species of fish he's looking for. What was the depth at which the diver finds the fish? So the diver did 4 different things. He dived 22 feet. Then he dived 7 feet. Then he swims back up 14 feet, and then he down another 14. So here is my suggestion to you guys. Whenever you have word problems like this, put all your negatives together and all your positives together. So when you dive and you go down into the water, well, I just gave it away. You're going down. So obviously you're going down below the water, so you're going negative. So every dive represents a negative. So I have a -22, and then I have a -7, and I have a -4. Okay? I have all these negatives. And then I have a positive 14. Okay? And it wants to know, where does he end up at basically? Where was his little fishy? Okay? So, when you have negatives or when you have positives, all you need to do is add all these up, and it's going to stay negative. So you're going to say -22 plus a -7 plus a -4, and you'll end up with a negative answer. And then once you get that answer, you're going to say negative answer plus 14. And that will give you the answer over here, okay? So, just like in class, when you're adding 2 different signs, you keep the sign of the larger absolute value, okay? So whatever number is here, is whichever one is larger, it's going to be that sign. So remember, absolute value is like this. The absolute value of -8 is equal to 8. The absolute value of 8 is equal to 8. It's not its opposite. What it is how far is -8 from 0? How far is 8 from 0? So you take these numbers and you find the larger absolute value, and that would be your answer, and then you just subtract. You just subtract what you get there, okay? Number 9. At 8 a.m., 26 children were at a daycare. By 3 p.m., 12 of these children were no longer there at the daycare. Which integer best represents the change in the number of children at the daycare from 8 to 3 p.m.? So, what happened to these 12? What did they do? Did they come back into the daycare, or did they leave the daycare? which math operation would it be if the 12 children were no longer there? So something happened. They left. When you left, would it be where you added or did you take away? All they want to know is what represents the change in the number of the children, okay? And the change, this is what we started out with. This is the change, okay? Number 10. I believe we've done this one before. Kind of looks familiar. Anyways, so we want to know what is the value of 3 3/4 divided by 1/4. Well, first thing, we cannot do division of fractions. So we want to do keep, change, flip. You only do it in division. You do not do it in multiplication. Anyways, before we do that, and whenever you have a mixed number, you want to go ahead, do the circle method and turn it into an improper fraction. So 4 times 3 is 12, plus 3 is 15. So I end up with 15/4 divided by 1/4. Now that I've turned it into two fractions, now I do keep, change, flip. So then it's going to be 15/4 times 4 out of 1. You get your answer. It goes in here. Be careful, guys. I'm seeing a lot of misunderstanding between a whole number and a fraction and where it goes in here. Sometimes you're getting the right number, but you're putting it in the wrong place. Okay? If it is a number, if it's like... If it's a number like that, then automatically you know it's a fraction because this number is smaller, okay? But if you end up with something, like, because the number on here is bigger than the numerator is bigger than the denominator, you know you're going to end up with some kind of a whole number. So even though this is a fraction, when I do this, I get a whole number, and whole numbers go in front of the decimal. Parts go behind, okay? These two have nothing to do with the question. I just want you to be careful when you get your number here. If you end up with a fraction, make sure you simplify it. You may get a whole number. You may get a fraction. That's for you to find out, okay? Number 11, what is the value of 3/8 times 16 33rds? Okay, so on here, this is a special kind of problem where we can do, which we talked about it just a teeny bit in class, sometimes in more classes than others, but we can cancel across, which helps us like simplify the fraction and make it easier to solve. So I know 8 goes into 16 twice, and 8 goes into itself one time. I know 3 goes into 33 11 times, and 3 goes into itself once. So I could rewrite this as 1 out of 1 times 2 out of 11. And then I can just multiply across and get my answer. Okay? I basically gave you the answer. Which equation is true? I want to say we've done this before, but I'm not for sure. So what I would do is I would take these and see if you can turn this into this. If you can turn this into this, okay? If you can turn this into this. So let me see. I'll try, let's do D together. This is 18 divided by 9. 18 divided by 9 is 2, and it's saying it's equal to 2/10. This is 2 wholes. Is 2 wholes the same as 2/10? No. Okay, you need to do that with each one of them until you can find which one of these is true. Which one where the left does equal the right. Okay, number 13, and we're almost done. This one is similar to the other one, but this one has, it's just written in a different way. Each of the 3 students wrote an equation. Nicole wrote 5 2/8 is equal to 21/4. Eric wrote 5 1400 is equal to 21/4. And Keisha wrote 4 1/5 is equal to 21/4. Which of these students wrote an equation that is true? Well, is it Nicole only, Nicole and Eric, Keisha only, or Nicole, Eric, and Keisha? Okay. So let me do one of these with you. So I will do this one right here. I'm going to do Keisha. Okay. So it's saying this is equal to this. So these are an improper fraction and a mixed number. But I can turn this into a mixed number by doing the circle method. 5 times 4 is 20. Plus 1 is 21/4. And it's saying it's equal to 21/4. Well, it is. So this one is true. Now your job is to see, are these true? Okay? Are these true? Looks like you're probably going to have to maybe turn this one. You can turn this one to a decimal by dividing, and same with this one. Once you do it for this guy, you'll have it for this guy. You can do this one and you can try simplifying it. This says 5 and 14/100ths or 5 and 7/50ths. Okay, so what you're trying to do is see which one of these, this equals this, this equals this. If this does not equal this, then it's not true. If this does not equal this, then it's not true. Okay, remember there's many ways that we can write numbers in equivalent forms. All right, number 14. A king snake is 31/50 meters long. What is the equivalent length of a king snake in meters? So, what I would do, like I've told you guys to do in class, is I would take the number given and I would write it all the ways that I know are true. So, this doesn't mean much to me except for I know that I can do this to it. 50 times 2 is 100, and 31 times 2 is going to be 62/100ths, okay? So I can get this fraction, and I can see that this right here, I look at this right here and it says 31/100ths, and I could write this like this, and I could see this does not match that. Now the 31 looks the same, but if I write this as a fraction, this is what it looks like. These two don't match. Anyways, I could say that, and then I could say, well, I know this is 62% because percent's out of 100, and I know this is 62/100ths, and I know it looks like that. Once I get my forms that I know this number is equivalent to, then I can look over here at my answer choices and see which one does or does not match up. Okay. All right, guys. Well, good luck. I will see you in class. If you have any questions, please let me know. Hey, guys, when you comment on YouTube, which I think is wonderful, and you have a question, please make sure that you leave me some kind of message, a specific message, like Mrs. Booth, number 5 doesn't make sense to me. Can you go over number 5 again? And I'll go over it. I'm getting some random comments like, this doesn't make sense. So Mrs. Booth doesn't know what doesn't make sense without you telling me what it is. So please let me know, and I will answer you back.